Greetings, Math 1. What I have for you today is basically a review of a little bit of the chapter that we did right before we went on break. It was the chapter over polynomials, which basically we're talking about how to classify them, how to add, subtract, and multiply them. So I'm just giving you guys a review on the basics of distributing monomials, that's a one-term polynomial, to a group of polynomials, and then simplifying the remaining one. So that basically just means how do you get rid of parentheses properly, and then how do you combine like terms after that. And we'll try to put them in standard form just to keep things as organized as we can. So without further ado, example 1. What I've given to you guys is 3 different polynomials, and we're not even distributing anything at this point. We're just saying I'm taking the first one, subtracting the second, adding the third. So, if you guys remember what we do in this case, if there is a positive kind of implied in front of a polynomial, that means it's almost like a positive 1. Here, if we're subtracting, it's almost like there's a negative 1 that's nested outside the set of parentheses. Same thing here. If it's positive, it's like a plus 1. Now, if you guys remember the distributive property, that basically means anything that is outside the parentheses here is going to be multiplied by all the parts on the inside. So you see with the first group and the last group, they both have positive 1s out front. So you can basically just drop the parentheses on those. So you've got 8 minus x squared minus 3x here. And you've got 9x plus 2x squared minus 3 from this one. Now the reason why I delayed on this middle one is because there's a negative 1 out front here, which means it's going to change the sign of everybody that was in the polynomial group inside the parentheses. So it was a positive 3x squared, but since it's a negative 1 times that, we're going to get a negative 3x squared here. Because it was a negative 4x, that negative 1 is going to change it to positive 4x, and then this positive 2 is going to change to a negative 2. So now it's kind of like I got a plus in front of this 9x, and yeah, this is the part where we can group together the like terms. If we want to put it in standard form, that just means biggest power to smallest power. So the biggest power in this case would be the x squareds. All right, so if I'm just going to collect these x squareds, maybe I'll use some different colors here to help us organize. So you got a negative x squared, a negative 3x squared, and a positive 2x squared. So we're basically taking negative 1 minus 3 plus 2. So negative 1 minus 3 is negative 4. Negative 4 plus 2 is negative 2. Now when you add or subtract like terms, okay, you add or subtract squares, you have to keep it exactly as it is. So the x squared terms added to or subtracted from one another remain as an x squared in the final answer. Okay? That's going to be a little different with multiplication. The next group should be the x's. And I believe that marker is past its due date, so I'm going to go back to the black marker. Negative 3 plus 4 is positive 1. Positive 1 plus 9 is positive 10. So you've got positive 10x. All right, then we add up our constants. You've got a positive 8 minus 2, that's positive 6. Positive 6 minus 3 is positive 3. Okay. So this is what I mean by simplify the remaining polynomial. This was a polynomial before we did any combining of like terms. When we grouped together all the squares, the x's, and the constants, that was us simplifying it. So the final answer is negative 2x squared plus 10x plus 3. Let's try another one where we're distributing something other than a 1 or a negative 1. All right. Once again, I'm down to the nitty-gritty. The markers I have they're the JV markers. They're the lowest quality I have, so it's a little messy. All right, I'm going to write this a little bigger so y'all can see it better. There we go. All right, so bottom line is if there's anything that's resting on the outside of the parentheses, that's indicating multiplication. So it's x multiplied by all the parts inside here. So I'm just going to take this one at a time. When you have an x times an x, that should give you an x squared. All right? Now, we weren't able to see x plus x equals 2x. All right? But x times x is equal to x squared. Addition and multiplication work very differently on polynomial terms. So keep that in mind. The power will change with multiplication. So x times 5x is 5x squared. There's two x's being multiplied by each other here. In this next part, it's x squared times another x. So that's going to create x to the third power with a coefficient of 3. All right, so this first group has been simplified right here. The second group just has a subtraction in front of it, which means we can say that this is exactly like multiplying by a negative 1. So that creates a negative 3x here. And a negative 1 times negative 2 is a positive 2 here. And then the last one, you're taking an x squared times an x. Again, that'll give you an x cubed. You multiply the coefficients, just like we did earlier. And then a 3x squared times a negative 1 creates a negative 3x squared. So now we collect the like terms. We're going to put the cubes out front because they're the biggest powers. So 3x cubed plus 6x cubed is 9x cubed. The x squareds go next. 5x squared minus 3x squared is positive 2x squared. And then these two parts won't actually be combinable. However, we still need to include them in the final polynomial answer. So the negative 3x comes next, and then the positive 2 is the caboose. And there's our final answer. All right, not too bad so far. This one incorporates multiple variables. Again, I will write it out so you guys can see it better. Okay, if there is a second variable involved or even a third variable, don't get too worried about it. Remember, like terms have identical variable parts. That means the same letter used for the variable as well as the same exponent. So there's nothing going to change when we're multiplying. It's all going to be in the addition and subtraction here. So when you see 3xy times x squared, you're saying that it's 3xy times x squared. The x squared is only being applied to the x term because we can use the commutative property that flips around these two. So now it's a matter of saying, oh, the rules of exponent properties means if I'm multiplying two powers of the same base, I can add their exponent together. So this is just going to be 3x cubed y, which should make sense. I mean, if that y weren't there, it's just a 3x times an x squared. That's 3x cubed. So you can mix and match the variables that should be multiplied together on this, kind of like what we did in the chapter previous to polynomials, the exponent properties. I actually made a video for Math 1B. If you guys want to check that out, it kind of underscores the thing I just talked about. So 3x cubed y will be our first term. The next one, all right, the 3 times the negative 3 will give us negative 9. The x doesn't have anybody to pair with, so it just kind of continues through. And then the y times the y gives us a y squared. So our first group comes out to be 3x cubed y minus 9x y squared. Our second group should go a little quicker because we now, I think, know we're doing a little bit better. A positive 5y times a positive 2x is 2 times 5 is 10. Yx, I'm going to flip those around and just make it xy. Again, the commutative property allows me to do that. Positive 5 times negative 5 is negative 25. You've got a y times a y squared, which gives you a bigger, like one extra power than the y squared, a y cubed. And then a positive 5 times a negative 3 gives you a negative 15. There's an x cubed already there, and then we're multiplying that by y. And then this 10y cubed that's just chilling out here is eventually, we'll hopefully get into the mix. All right, we've got a new polynomial. A lot of stuff's going on. Just make sure you're thinking, I need identical variable parts. So this x cubed y has to match up with another x cubed y, which is what we have over here. All right, so identical variable parts. We've got x cubed y, x cubed y. We can combine the numbers in front, their coefficients. So 3 minus 15 is negative 12. And then we leave the variable expression as it is, xxxy. X cubed y is what is attached to it. So don't worry too much about standard form if it's kind of messy, mixing and matching x's and y's and whatnot. Just make sure you're combining the right like terms. So a y cubed and a y cubed are going to create a new coefficient, negative 25 plus 10. That's negative 15. And they get a y cubed with it. And then you just throw the leftovers at the end. Since this one has an x, y, y, that's a 3-term, that's kind of like a degree 3 part. That should come before the x, y, which is a degree 2 part. Although I'm not gonna penalize people for not putting things in standard form. But again, we're reviewing this stuff, so it should make sense. It has been a couple weeks. It has been a couple weeks, though. So, minus 9xy squared plus 10xy. All right, I've only got a couple minutes left, so I want you guys to try number 4 on your own. Pause the video. And then I'll see if I can get this down on whiteboard in about 1 minute. So at least you guys have the answer. All right, it's probably not in standard form, but it should be the correct answer. Go ahead and check Google Classroom for the rest.